Welcome to Understand the Math. In this problem, we're going to find the value of h for which the following vectors are linearly dependent. Let's notice that h is down here in vector v3. Let's talk about a little bit of theory before we dive into the solution of this problem. Vectors will be linearly dependent if the linear combination of these vectors c1v1 plus c2v2 plus c3v3 is equal to 0 has a non-trivial solution. That means a solution that is not equal to 0. So in practice, here's what we have to do. We have to start with a matrix, and in that matrix, we're going to put vectors v1, v2, and v3. We're then going to put it in echelon form. The reason for this is that we want to see what type of solution we have. And we're going to choose H so that there is a column without a pivot. Whenever we have a column without a pivot, we are going to have a non-trivial solution. If every column has a pivot, the only solution to this equation right here is going to be that C1, C2, and C3 are equal to 0. So what we're going to do is we're going to have to force it to have a column without a pivot. So we're going to take our matrix and we're going to put vector v1 in the first column. So we have a 3, minus 3, and a 6. We're going to put vector v2 in the second column and then vector v3 in our third column. And we're going to put this in echelon form. So I'm going to start by circling our pivot, and then I'm going to highlight the two entries that have to go to 0. The row operation that we're going to use is we're going to say that row 2 is going to go to row 2 plus row 1, and then row 3 is going to go to row 3 minus 2 times row 1. Let's go ahead and let's do this. Our first row stays the same. And then our second row, we're going to add our first row to it. So we're going to get a 0. A minus 9 plus 6 gives us a minus 3. And then a 2 minus 2 gives us a 0. Now we're going to change the third row. We're going to multiply the first row by minus 2 and add it to the third row. So we get a 0. We pick up a minus 12 plus 11 gives us a minus 1. And then a 4 plus h, so we'll write that as h plus 4. Now let's circle our next pivot. It's going to be a lot easier to work if this pivot is equal to 1. So what we're going to do is a scaling, and we're going to take row 2, and we're going to replace it with row 2 divided by minus 3. So our first row is going to stay the same. Our second row, we're going to divide by minus 3, so we get a 0, 1, 0. And then our third row stays the same. Now let's go ahead and let's circle our pivot. And this negative 1 is going to have to go to 0. So we're going to take row 3, and we're going to replace it with row 3 plus row 2. We'll give ourselves a little bit more space. Our first two rows are going to be the same. So we have a 3, 6, minus 2, and then a 0, 1, 0. And now we're going to take our second row, add it to our third row, and we have a 0, 0, h plus 4. Now, in order for our vectors to be linearly dependent, we have to have a column without a pivot. Let's go ahead and let's circle our pivots. And we can see that the only way that we can have a column without a pivot is if we make this pivot equal to 0, which means it's not going to have a pivot. So here we go. We're going to take h plus 4, and we're going to set it equal to 0, and that's going to give us an answer that h is equal to minus 4. So when h is equal to minus 4, we have a column without a pivot, and our vectors are going to be linearly dependent. if we wanted our vectors to be linearly independent, we would have to make sure that h plus 4 was not equal to 0.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.